In the previous video, we saw the problems involved in strain gauge. Now we will see the problems involved in temperature sensors. So, if you say there are different temperature sensors, one is RTD thermistors, another one is thermocouple. Thermocouple we'll see at last. First, we will complete RTD and thermistor. Okay. So, one of the most common problems that you might find in the RTD space is this kind of linear approximation versus quadratic approximation. So linear approximation, as I told in the lecture video, linear approximation is you fit. So you have this curve. So you have this plot, set of temperatures in x-axis and set of resistance in y-axis. So when you plot it, you will get a straight line. If you get a straight line, it's fine. But most of the RTDs, the resistance temperature detector material, will also have asymptotic type. So you need to go for quadratic. So what does that mean? So I will fit a line. Okay, that line's equation is y equal to mx plus c or something like this. Okay, so you need to find how the linear approximation. So what is how can you go find a linear approximation equation and quadratic approximation equation when set of temperature and resistance are given. Okay, so here set of temperatures, so for 90 degrees to 130 degrees they are giving different resistance values. Okay, and they are very clearly they have told that about a mean of 115 degrees. So what is the mean? Here you add these two values and you divide by 2, you will get 115 degrees, and the mean is about 115 degrees is the value they have asked us to take. So that value is the theta 0 value. Okay, so resistance at 100 degrees centigrade you need to find, that is 573.40. Similarly at 115 you need to find, that is some 5 okay, that is 589.48, and resistance 130 degrees is 605.52. You then substitute these values to find your alpha 1. So alpha 1 is temperature coefficient, right? So you know theta 2 minus theta 1, which is the max temperature minus your max temperature minus mean temperature is not your theta 1 here, because here they have asked to find approximation between two temperatures and the mean temperature is 115, right? Actually the max and means are different, so you should be very careful. Initially when you do that, people usually take min and max based on their experience in the previous unit. Please don't do that mistake. Here theta 2 is whatever the temperature they have asked, kindly take it from that value, that is theta 2 minus theta 1, and their corresponding resistances, and resistance of 115 ohms, that is 589.48. that will result in a alpha value which is 0.00182 ohms per ohms degree centigrade. Then you substitute in the equation where the r theta 0 into 1 plus alpha 1 into theta minus 115. So what you get is you get a linear approximation equation. So what is the significance of this equation? For any temperature you give between 90 and 130, you substitute in this, you should get a corresponding resistance. Kindly find it. Okay, check it and you can get it. Similarly, you can do the same operation for quadratic equation. So what you will be doing for quadratic equation, 100 to 115. Here the delta T2 is if you see you need to do it for the quadratic equation and get the values similarly, but okay, and you tell the results. Okay, so you can do the same approximation, but only one difference which I am able to find is the quadratic equations will take from point to point. So for use, what you can do is we can find the quadratic equations by forming two equations, 2 points. Okay, so that is r theta 0 and the corresponding temperature. Now using 100 and 130 as 2 points, we get two equations. Okay, so what are those two equations? One is in one point theta 100 minus 115. Okay, 100 minus 115. In another point you will get 130 minus 115. Two different temperatures and the mean temperature. Okay, mean temperature you should take. That is what they would have told in the quadratic where is the quadratic approximation? Yeah, if you see, this is what they would have told. So delta is for with respect to mean, you need to take it, then you will arrive at alpha 1 and alpha 2, then use the alpha 1 and alpha 2 here and you arrive at this equation. So any equation, now you will get up until two decimal spaces. Okay, until to 0.77 you will get a correct value of your resistance when you substitute any of those values into this equation. So see, all these are numbers except theta. Okay, when you substitute theta here, that can be 90 or something, you will get r theta, which is 562.66. okay.